All right, so we are live. Hi everyone, I'm really excited for this live stream. Today I'm interviewing Professor Qiusheng Wu, and he's an assistant professor in Department of Geography at University of Tennessee. His research interest lies on GIS, remote sensing, and environmental modeling with more focus on applications of geospatial big data, machine learning, and cloud computing to study global environment change. A lot of and packages he developed are open source, and more information can be found on wetlands.io website. And he has developed amazing tutorials on his YouTube channel. I highly recommend all of you to go through it, because when I went through it, a lot of functionality, a lot of important software development tutorials was also shared. So thanks a lot, Professor Q, for your time to do this interview.
Thank you, Mayor, for having me. It's an honor to be on this interview, and I'll have to discuss anything that related to the package that I develop or something in general for the geospatial data science.
Mhm. So, Professor Q, can you tell us about your background, where you grew up, and why you chose to study geography?
So I kind of it's a kind of accident. I didn't. I chose to study. Went to try to go to a medical school, but my score was not high enough to get into a medical school. So I was actually assigned to do geography information system, and so I think back in 2005, and at that time Google Earth came to it was just released I think back roughly 2005, and it was amazing. So I was amazed by the satellite imagery and all the capability that you can use some application to actually visualize the changes of the earth. And eventually I go into more about the desktop application, for example, in the leading GS software called ArcGIS at that time, and I have been using that for a long time. But this commercial software is closed source, although it's very powerful, very popular. But I always want to explore more potentials. So eventually, I go into more open source during the past few years, and then it's just tons of projects on GitHub that you can learn from. And if you have time, you just spend a couple hours and then reading through a project. You learn a lot of things, and then you read through the documentation. Then you can come up with some idea that, or how can I build on top of the packages that other people have developed, and to make things easier for other people. And so that's what I'm have been working on during the past roughly 2 years, and mostly it's open source. So
I see. And like, can you share your coding process? Like, how did you learn coding? And like, if you had face a problem, how did you approach?
yeah, so coding actually, I learned um, Visual Basic and C in college, but those are just basically some uh, theoretical foundations. We didn't really have some real world application to work on at that time. So, and then after I came to US in 2009, so, and I got my master degree and PhD at the University of Cincinnati. So at that time I learned Python by myself, and so during the past few years I primarily use Python, but I also learn R. Most of those languages I learned by myself. So I think the most important thing is to know the concepts. Once you know the concepts, usually they share a lot of commonality between those languages, for example, Python, R, or C++. So once you get the idea how to do some, to think like a computer science. I don't have formal training in computer science, but I do learn by myself through some books and videos and tutorials, and try to master a language very well. At the beginning, I tried to learn every language. I tried to learn C++, Java, and Python, and right now I pretty much end up with just Python. So although I use other languages a little bit, but I like really Python because it's very easy to learn, and there are tons of resources you can find online. And so initially when I got into I think roughly 2 years ago, I go into Google's engine. And so at that time, Google's engine was just um, getting started. It's not very widely used yet, but they have a JavaScript interface. So I learned JavaScript and learned how to use it. But personally, I couldn't really master JavaScript because it gets quite complicated when you're trying to design user interface. So then I get into the Python, but Python, the Google's engine does not have really have visualization functionality. So you can do everything like using the coding, but you cannot really see the result interactively. And then so I kind of went back to JavaScript again, and then I came back to Python because at that time I realized it was possible to do some of the interactive mapping using the Folium or IPyLeaflet packages. And then I go into those packages, learn how to use them. And so eventually I build on top of those packages to provide some interactive functionality for visualizing Google's engine data and also computational results. Just make things much easier. So now it's a lot of things you can do a lot easier compared to JavaScript using Gmap.
I see. And you mentioned like you started coding like 2 years ago, and like what made you realize that uh, coding is gonna be really crucial skill for future GIS related research or data science aspect?
It's going to make things make life much easier. So it's not just for doing research and teaching. It also help you personally life. You can automate a lot of things. So a lot of things, if you need to do things repeatedly, then you can somehow use programming to help you. And so uh, especially for example in GS geospatial data science, we need to deal with a lot of data sets, a lot of satellite imagery, a lot of vector data set. Most of the time you're trying to do things repetitively because if you, for example, you're trying to do a study for the entire US, and sometimes, for example, the data set might be too big and you need to go small pieces by small pieces. They say you want to do that by state. Okay, so we need to go through, for example, 50 states, do it one by one. If you use some desktop software, you need to click the button like repeatedly to click the button until you finish everything. And sometimes something goes wrong, you need to basically figure out, or you may forget, okay, which state I'm processing right now. And it's kind of a mess when you don't really know how to automate things. So if you use Python or other languages, you can easily write a loop, for example, and just to do things easily. So 50 states, you might be able to basically manually do that. But if you're doing for counties by county, if you're trying to aggregate things by county, you have thousands. There's no way you want to do that by clicking your mouse. So if you know how to program, it's only the couple of lines and then you can do things nicely. And if something goes wrong or you need to redo it, just change some parameters and it's going to save you tons of time. So I highly recommend that if you haven't like started programming yet, just learn Python and then you can use that to automate a lot of things. It can also help you handle some of the files on your computer. It doesn't have to do like geoprocessing or computer science. It can help you, for example, rename some of the files. You can move the file from certain directory to a certain directory. So um, very easy to use. So that it's going to make your life much easier, and you can help you conceptualize your thinking and how to, for example, if I have a project, how do I do it from the start, from the beginning, and how do I automate the things, and how can you transfer the skills that you learn in one project to another, because they most likely share some common things. You were trying to basically do things step by step, or you have some proper protocol you need to follow. And if you know how to do that for one, you can easily adapt that to do that for other projects.
I see. I recall like an article like automate the boring stuff with Python,
Yes.
and it
Yeah.
like there are many like small tasks even in like on day-to-day basis one could
Mhm.
automate using Python. So I totally resonate with your point that uh, a lot of tedious or
Mhm.
smart productivity can be increased through programming.
Mhm. Let me give you another quick example. They say if you're using Windows, after you install the system, you have all kind of software packages that you need to install. It might take you a couple hours, right? You need to download the software from the internet, and then you need to do it one by one. But if you use Linux, you just have one batch script. And then to me, I don't care about like how many packages that you need. I just put into the script, and then after install the operating system, I just run that script. It takes you a couple seconds, and then things get done automatically. So it's going to save you tons of time if you know how to do the coding. Either it's doing some simple batch processing, or doing Python or R, whatever. So certainly it's a skill that uh, would be nice to have, although it's not required. Not everyone is comfortable with coding, but if you have that courage to learn a little bit, you can utilize it in your daily life, or make your life much easier.
I see.
Mhm.
Uh, can you give us an overview about the projects you did till date?
Mhm. You mean for the Gmap, or what do you specifically?
Like in general, like what kind of research you did in
Okay.
the GIS domain, software
Mhm.
development? Yeah, yeah.
Mhm. I'm right now focus on mapping surface water and wetlands. So trying to see the changes, the dynamics of the surface water body, and how what are the drivers for those changes. So trying to see, especially right now, we have a lot of satellite imagery, right? Back in the 1970s up to now, so we have almost 40 years of data, and you have also this spatial resolution varies, right, from coast resolution kilometers to right now centimeters of data, and a lot of data in the public domain, so we can utilize those data. One example, for example, you use Google Earth, right? When you zoom in using Google Earth, at the beginning it's just an overview, right, a global scale, but when you zoom in, the resolution changes, and the satellite imagery also changes. So there's those data come from different sensors, different satellites, and how we can utilize those imagery to extract some information, trying to figure out, for example, the changes. And they say, for example, if some natural disaster before and after, how do you evaluate the changes? How do you assess the damage, and how we can quickly respond or prioritize the resources to deal with those environmental issues? In the past, when we don't really have cloud computing yet, we need to actually download all the satellite data to your computer and then do processing. Think about if you're trying to deal with a global scale, 30 meter by 30 meter, or right now even 1 meter by 1 meter, you cannot really process those data using your desktop computing, because one thing is the data storage. So it's many terabyte, or right now it may be petabyte of data that you need to store. And for personal laptop or computer, it's just not going to be able to handle that kind of a data storage. And besides data storage, about computing. So if you're trying to classify the imagery using machine learning or deep learning, then you need a lot of computing power. And you can do that for small scale, but when you're trying to do that for large scale, it's just simply impossible. And satellite imagery is somehow different from the computer science, like JPEG or PNG. It's different because we have multispectral bands, and also sometimes you have hyperspectral, you have hundreds of bands. So the data volume is much larger than the traditional remote image classification in computer science. And usually we're dealing with terabytes data. And so the best way that we can right now tackle this problem is to use cloud computing. And there are a lot of cloud computing, free cloud computing resources out there that people can utilize. So for me, the project like right now I'm working on is trying to develop some packages that, for example, Gmap or Leafmap, make it easier for other people to utilize those cloud computing resources, and how to, for example, load the data, visualize the data, and also how to display the result interactively. So anyone, even without coding skills, they can still go online, type the URL, and then visualize data nicely, just like you go to Google Map and Google Earth. But keep in mind the difference between, for example, Google Earth Engine and Google Earth is that Google is just a collection of images. There's not really much information, results or computation results or scientific analysis. It's just photos. So similar to the computer science, right? You might have a photo of images or photos, but if you use some deep learning or other algorithm, you can identify how many people in that photo, how many dogs, how many cats, how many animals, something like that. So similarly, in the Google's engine, we can do computation. We can extract some information, quantitative information out of that, right? So in the geospatial domain, some of the question that we can address is that if you see the imagery on Google Earth, for example, you can see that, oh, okay, the urban area is growing, okay, the population is growing, but Google Earth cannot help you answer the question, how much of the growth, what's the growth rate, right? How much area has been expanded? You cannot really answer the question. You can visually see that, okay, it's changing, but how much, 10%, 20%? You don't know. So that's why we can use Google's engine to actually acquire the imagery, do the computation, and then eventually do some quantitative scientific analysis to address some of the questions that you want to answer.
I see, I see. So if I get it right, we are taking like those raster based analysis, extracting like what's the ground coverage, what's the water,
Mhm.
and like numeric value, and based on the past historic data, like we can develop some data driven solutions that based on past 50 years, if this is the situation, what
Mhm.
kind of predictive models can help us to develop the situation in like future or next 5 years. So
Exactly. Yes. Mhm.
I- And I would like to discuss a bit about the feature engineering. So, for example, uh, Google Earth Engine might have like some built-in features of like let's say land, water,
Mhm.
and what kind of additional features one could extract on top of it, and how can like relationship can be developed among those like variables or features.
It actually depends what you need. It can pretty much detect any feature that you can detect. So it depends on the spatial resolution of the imagery. If you're looking at very close resolution imagery, for example, the Landsat data 30 meter, you probably won't be able to see a car on the imagery, right? So it depends on the feature, the size of the feature that or the target that you're interested in. If you're interested in very small features, then you need higher resolution. But you can have some, for example, 1 meter right now. The best freely available imagery at the national scale is 1 meter resolution from the USDA, the so-called net imagery. So, but you can, for the coastal resolution, you can get 30 meter, 1 kilometer. So depends on the features you're interested in and depends on the satellite sensor and also the availability of the data in your study area. So once you have the image, you can decide what kind of feature I can detect. So we can detect, for example, trees, buildings, swimming pool, anything like that. So as long as you can see human visually, you can see that from the imagery. Somehow you can use some machine learning or deep learning to actually to train the algorithm to detect those features. But the accuracy might vary. So if I'm doing some very small features, the accuracy might not be as high compared you are doing some very general feature, for example, just urban area compared to okay individual building. It's two different tasks, but theoretically they're the same. It's just some feature on the imagery, and you can, if you have some training data, you can apply the algorithm to easily to classify the imagery and then do some also accuracy assessment.
I see. And like I'm just wondering, like if I'm developing, let's say, a problem that I want to study how the land usage change because of gentrification problem in a city,
Mhm.
I could like monitor that data. But let's say if I'm comparing two cities, gentrification problem, like how are external factors like what if there was a flooding in a city, what if there is a policy change, like can be incorporated along with this geospatial data, because a lot of factors might contribute to the
Mhm.
predictive problem we are solving apart from like spatial data.
Mhm. Yeah, so that one also depends on your model. So it depends on the problem that you are dealing with. You can certainly in, so if you're just looking at the image itself is just the facts, right? It just shows you what the pattern. But in order to show the pattern, there's some processes behind the pattern. So you're trying to figure out why this is happening. So it might be just natural factors, but there are also a lot of, for example, human factors that contribute to the changes. So if you're building up some model, then you can certainly incorporate some, for example, social economic factors into your model to do some, for example, regression, or you can do some decision tree. So eventually you can incorporate some of those into your model to better explain the changes. So they say you have two study area, they might change the same amount. For example, the urban area might grow the same area, but the speed might be different, right? Some might take 10 years to grow that much, some might only take 1 or 2 years. So in that way, you can eventually figure out, okay, why this one is changing much faster compared to the other one, because of some things that is happening here in the area, or whatever policy changes, or the government have some incentive or whatever. Then you can try to explain in details why this is happening.
I see. Yeah. And just to like get it clear, so Gmap is a Python package for interactive mapping with Google Earth Engine, and Leafmap is for people who don't have Google Earth Engine account and like
Mhm.
using like other libraries, integrating
Mhm.
with other libraries like Folium,
Mhm.
etc., to provide such visualization and analysis functions.
Yeah, it's very close. So initially I developed Gmap, and it gets quite popular in the geospatial community. So because Google Earth Engine itself has the Google Earth Engine Python API, but it's just for doing computation. You cannot really visualize the result. So for example, after you develop the result, you can print out a thumbnail, just like a static imagery. If you have thousands of images that you're trying to go through, it's just simply impossible. So, and Gmap basically helps users to quickly visualize the result and then do some interactive mapping. You can display the data, you can display computational result, you can also create some graph and also create some animations like that. But the problem is that you need to have a Google's Engine account. So people might not everyone has an account, and some also for some other companies, for example, Google's Engine for research and education is free, but you cannot use it for commercial purposes, and you need to actually contact them for the licenses. And um, a lot of people try to avoid using this kind of a commercial stuff in their company because they don't want to pay. And so eventually I saw, okay, maybe I start trying to separate those two components and trying to maybe build another package that anyone can use. If they just go online, they don't need a Google's Engine account, they can do some analysis, they can do interactive mapping. So that would be something that I think more interesting for the general public. And then so last week, not last week, I think this past, I think I released it on Tuesday, and so it gets quite popular. Just only a couple of days, it already have more than 500 stars on GitHub. So I think a lot of people are interested in that one, and because you just need to click the link and then go to, for example, Google Colab, and then you can execute the source code. You can see the map. You can display the data. You can also do all kind of analysis directly using the package without having to use Google's engine. And if a company that interested in this kind of technology, you can use that. It's free, and then you don't need to pay anybody anything. So hopefully it will be useful for the research and teaching and other people. You can also use that to publish some map. So they say you have some imagery, and then after you collect the imagery, you want to share with anyone. You don't really have a way to do that. You can use the app to load the data, and then eventually just one line of code to publish that as an interactive web app on the internet. So anyone just go to the URL, they can visualize, they can do some manipulation with the map.
Got it.
Mhm.
And like I could only imagine how much effort and work it might go to develop such kind of package.
Mhm.
So can you like share us the process of creation of Gmap? What was the approach, motivation behind it, challenges faced in developing functionality?
Mhm. So initially, I was teaching last year. I was teaching a spatial data management course here at my university, University of Tennessee. I was teaching, it's an undergraduate level course, and so I was teaching students how to use Google's engine. So as I mentioned, it was difficult because you cannot visualize the data interactively. So and then I developed Gmap just for my students, and then but I released to GitHub anyway, and it got kind of attention from the community. Then I try to continue to build up the package. So at the beginning, it was very simple, just trying to just display the data interactively on the map. And the first package I used was called Folium. So Folium is also a very popular library in the in the community that you can use to do interactive mapping, but it has quite some limitation because it's just like one-way street. Once the map is created, you cannot actually modify the map. You can only zoom in and zoom out. That's it, pretty much. But if you're using Google's engine, something that we always want to do, if for example, if you click your mouse on the map, you want to get the coordinates of the mouse, and then you use the coordinates to extract, for example, the value or the time series or pixel values from the image. You cannot do that using Folium. So later on, I go into IPyLeaflet. So that one is built on top of IPy widget. It's more like two-directional. So once after the map is created, you can modify the layer, you can remove a layer, you can add a layer, you can add some components, you can add some widgets, you can develop a lot of interactive graphical user interface and put it on the map. So a user can just go to the map, and then they don't have to deal with the coding. They can click their mouse, and then so eventually I try to switch to IPyLeaflet. But the reason that I use both is because Google Colab, a lot of people use Google Colab, and Google Colab does not support IPyLeaflet due to some security reason. And so in order to be able to balance, like, people, you don't need to set up Jupyter notebook on computer, you can use Colab. But I also use Folium in there so people can still display the map interactively. But if you really want to enjoy the interactive capability of the package, I would suggest that you install Jupyter Notebook on computer, and then once you set up, it will be going to make your life much easier because you can do all kinds of computation just for free. You can access to the, right now I think it's more than 35 petabyte of data for free, and you can do that for running computation at the global scale or at the national scale. And if you're trying to use a desktop computing, it's going to take you months, weeks to actually process the data. And if you don't use Google's engine, you can still use Leafmap. So that one you can pretty much use it anywhere. There's not really any barrier. You can go to my the Leafmap package website, and then you can go through those examples. And those examples right now are also interactive. So there are lots of maps that you can just zoom in and zoom out. You can take a look at the results.
I see. And like, in order to develop a package, like, so first, is it the way like you thought, okay, what kind of functions that would be useful for students or people to visualize or feature? Then you develop those functions, and then I think if you want to develop a Python package, like, if one needs to install, they need like pip install a package. So you might need to like wrap all the functions in a library. Like, how is that process?
So in general, in the past, at the beginning, you can, so depends on how complicated you want to go. You can certainly just start everything from scratch. But there are also some templates, so-called cookie cutter template. And then I actually have another package that you can use to actually build a package. So you have all the files necessary for a package. You can also build up the documentation, and you only maybe take you less than 5 minutes to set up a package template. And then you can release that one to PyPI so that anyone can install the package. You can also release to Conda. And on my YouTube channel, I have a course called Geographic Software Design. That one teaches people how to develop a package from the scratch, from the very beginning to the end, and how to add functionalities, and how to develop novel examples, how to build up the documentation. And so for package, the framework, the protocol, the prototype is actually very easy. You can use the template that I developed, and it has the source code, some like backbone, and you can also have the documentation website that you can use to host on GitHub pages is for free. So anything that right now you see, for example, from the gmap.org, you see the documentation website, that one is hosting on GitHub, so it's free. You don't really have to pay to buy hosting space to host your website. So, and the more important thing is to think about what kind of functionality you want to add, because once you have those modules, the process is pretty much similar. You have a function, and put a function into a class, and within that, you need to think about what kind of function will be useful. Some of the features that I already know that will be useful, because personally I use that a lot, so I know what I'm looking for. But there's also a lot of new features that request by the users. So somebody asks a question on GitHub, okay, can you do this? Is this possible? And then I think about, okay, it might be possible. Then this may let me implement it. And so if a function, then you need to have some kind of arguments or parameters, what kind of arguments I need to provide. So eventually you're trying to make a function that can be generalized, that anyone can use. And once you write the source code, then you can develop some Jupyter Notebook example that utilize the function. So if you see my YouTube channel, I have a lot of videos. Like right now, I think 50, 60 for that one. But for the notebook examples, I already developed maybe I think 70 or 80 notebook examples. I don't have time to record every new feature for that, but I try to actually introduce educate people how to use the new features, because a lot of them might be hidden in the package. You need to read the source code. You need to know what kind of function available. So, and once you develop a couple of functions, then you know exactly how to get started if you need to develop new ones. So you just add to the script, and then follow the procedure to define think about what kind of name I want to use for this function. So it need to be something meaningful and not too long, and what kind of arguments. So you try to follow the convention, and then use some best practice to basically make your code efficient, and also trying to make it easier for other people to understand. Eventually, is to pick up everything that you do it randomly on your computer. They just do it for one time to make it something that can be used by other people. And so just to make things easier. For example, in the past, if you're trying to add some data display on the map, you need to write a lot of coding. Okay, how to download the data, how to get the data to your computer, and then process in a format that can be utilized by the program, and then how to do analysis. So you can think about the procedure that people need to go through, and it would be nice to be that people don't need to do coding. You just click the button and then open a file, and then it display on the computer. Just like, for example, Microsoft Word document, right? People don't have to use all kind of programs to write text and then use different program to actually do that. You just click open and then open a file. You can open multiple formats, right? Not just Word document. You can open other type TXT, something like that. So rather than doing coding to ask people to go through many steps, you just simplify the procedure, and then people just click a button and then get things done. So it'll be nice. Mhm.
I see. So let's say someone requested an animation feature. So if I visualize it right, then in order to develop that function in one needs to know like what's the coordinate zoom level,
Mhm.
uh, and also the time frame for that
Mhm.
animation.
Mhm.
So like one might need to think like back way, what kind of arguments one needs, is there a for loop one needs to run to do from like this coordinate to this coordinate for like this many time frames and
Mhm.
develop the animation, like writing down like step by step, cutting it
Mhm.
to like, and in the back end those functions can be developed. Is that the process?
Yeah, so basically, for example, if you're trying to develop some interactive user interface, then before you do that, forget about the user interface. Think about how you can do that, like in programming, just like a function, they can do the stuff. And after you finish the programming, then you can think about how do I design the user interface? What kind of arguments I want the user to be able to control? And then you can divide the user interface. For example, in Python or Jupyter Notebook, you can use IPy widget. You can have a drop-down list, you can have a slider, you can have an input box or checkbox, something like that. So eventually the user, whatever they click on the interface, it's going to get some values. Then you can pass those values into the function. So behind the scene is calling the function. So you need to develop the function first, and then design the user interface, and then eventually can integrate them together. Because some people might want to use interface, but there's still a lot of people might want to automate the things. So if you want to automate, you try to avoid using the graphical user interface. You want to be still to utilize the function. So behind the scene is calling the function, but for those non beginners, you see the interface. But for the advanced users, if they're interested in a function, they can look into the source code. Everything is on the documentation website. You can look at the API reference, and then you can see the source code. Just click the button, and then you'll be able to see the source code. So some of those might be quite simple, maybe a couple lines, but some can get quite complicated. So some of the functions that I develop, it's sometimes more than 1,000 lines of code. So it takes sometimes hours, even weeks actually, to finish that one. So a lot of thinking in the process, that okay, how do I get this one, and then a lot of debugging. So especially when interface kind of involve multiple functions, sometimes it gets quite complicated. A lot of widgets, for example, user click this button, it's going to show you a graph on the map. If you click another button, it's going to show you some other things. And those interactive widgets, you need to basically control all of them, because sometimes if you have too many widgets, so it gets more overwhelming and things are not being clear up correctly. Sometimes it gets quite slow. So you need to load things behind the scene, how to do it properly, so that your programs can still be quite efficient, rather than using a lot of memory on your computer.
I see. It makes a lot of sense, and I could like imagine, like if the function is complex, there are a lot of dependency and
Mhm.
also other library integration in that function, which
Mhm.
makes it a bit challenging for debugging.
Yeah, especially right now, there's so many different user has have different configuration on the computer. Some use Windows, some use Mac or Linux or other computer system. And even for Python, right, you can use pip, you can use corner. There's so many options or potentials. And so when you develop function, I need to think about how to actually think about to automate, to make it work on multiple platforms and different versions. So sometimes it can be quite tricky, but right now you can use GitHub Actions to automate. So I'm using Linux. So when I develop package, most of the functions based on Linux. But when you push to GitHub, you can automate, do the testing for other operating systems, so Windows and Mac, make sure that people can install correctly. Otherwise, if I need to do that manually, it's going to be a headache. I need to have multiple computers, multiple operating system, and then do the testing. It's not going to be easy. But thanks to all the tools they offer right now, and it can certainly make things easier for us to develop our packages.
I see. Yeah. And can you like provide us like a code review of a particular function just to
Mhm.
get an idea how much work it gets into?
Uh, so for example, this one it varies, depends on the function. So as I mentioned, it can be sometimes can be just 5 or 6 lines. Sometimes can be get hundreds of or more than 1,000 lines of code. So um, most of the functions built on top of other packages. For example, do you want me to share my screen, or you just want to talk like this?
Yeah, like if you can share your screen, it
Okay,
would be awesome. Yeah.
let me take a look here. Can you see my screen now?
Yep.
So for example, if you're interested in a certain function, for example, you can click the API reference. You can also go to the gmap.org, and then from here, you should be able to see a lot of functions. And so you can click, for example, the common module. So this is a module that with the function that share between IPyLib and or some of the function that does not involve the user interface. So you can use the command line. And we can maybe just take a look at this one here, a simple one, add image to GF. So basically, once you create the animation, you might want to have some logos display on the animation, right? So you can certainly use this one to do that. And if you click here, the source code, right? And if you scroll down, this one it gets a little bit complicated. So probably maybe a couple less than 100 lines of code. So this is the name of the function, and these are all the arguments, right? So you need to think about what kind of arguments are required and what kind of argument can be optional. They allow the user to provide, because the function, if you have too many arguments, you don't want the user to provide every detail, right? You should think about how to make things easier for the user, and you also have the explanation what each parameter means. And then from here, basically, you try, if you're importing some library, you can import the library. Other than that, there are a lot of things you need to deal with, especially if you're dealing with files on your computer. You need to make sure that the user provide the correct file. If it doesn't, then you need to throw some error like, okay, the file doesn't exist, or you need to select the correct file, and then you can go through the process how to do that. For example, add some images, and then if something goes wrong, you need to let the user know what's wrong, right? So there are a lot of things you can do within the function to make things work correctly, and then provide the results. So you need to do a lot of also testing. But there are a lot of functions here. If you scroll down, this one right now, I think is more a couple hundred functions that you can use. For example, you can convert file. They say here you can show an image on the browser using Jupyter Notebook, right? So you just call a function and then pass the image path. You can also set the width and height. So this is more like specifically related to Google's engine, something more like a general that user can use to display an image on the map, on the browser. And this one is basically quite simple, right? It builds on top of the IPython, and then use IPy widget to open the image and then put the image within the widget, and then also display the widget on the browser. So if you're interested in any function, you can also do a quick search in here. For example, I can just type show image, right? And then you can click. You will navigate to whatever function that you click. Then you can look at the source code. So you can also have the functions, everything. So these are all automated. I actually don't build up the documentation manually. Everything is automated using GitHub. So if you go to the GitHub webpage, and then under the GitHub, right, workflows, and then docs YML. So this one here, this is all the build up the documentation, and it's using the so-called mkdocs. And there's a file here called mkdocs, right? So this one, they basically the template, the navigation of the web page, right? So everything is basically doing in here. And the most important thing is make sure that you have the so-called Docstring document the function properly, so that you can automatically extract the information from the package. So I can show you some example. If you click the Gmap and let's look at this one, the command.pr, this is the function. So when I develop function, after I finish the function, then you need to write detailed documentation. Okay, so in here, if you scroll down, you see this one right now is getting quite, it's probably the longest script that of the package, and it might be just the internet. It doesn't even load correctly. Let me see here. So if you scroll down, you should be able to see some documentation. No, this one, right? So see here, if you see this one, this is the name of the function, and also have the arguments. So if you have this set up correctly in your script, when the package is being built, it's going to extract the information and then display that one as a function here, and then you can have something like this automatically. So if you go back to, for example, for the any function, if you have the documentation, it's going to extract the text and also the type and also the source code. So this is basically all automated. And if you want to learn more about this, let me close this one. It's just too slow. So on my YouTube channel, there's a course there that I mentioned earlier that teach everything from start to the end, how to develop packages and how to build up documentation and how to release to GitHub and PyPI, also contact, so that people can install their package from anywhere. So this is the one here, this one. So it has 38 videos, 18 hours. And that's the course that actually I taught last semester here at the University of Tennessee. But I try to make those videos more journal that anyone can follow, and you can go through the video if you even interested in a specific topic, and it covers most of the common tools that I use, and also the functions or some of the things that I think is useful. This is not just to the geospatial data science. It can also be something very general to anyone want to develop package. For example, publish package on Conda Force, or how to update the package, how to sync, right? Some are more like related to just Google's engine or geospatial, but a lot of things are very common if you're trying to develop something for the open source community.
Yeah, I think this is very useful stuff. Like even I was not aware about like automating the functions from GitHub, and when I saw it, it's really good feature. It saves a lot of time, and like if one thinks of about like using this workflow, then maybe while defining the function, having a proper structure will save a lot of time in future.
So for example, for the website, it's actually hosted here on GitHub. So under the GitHub pages, so whenever you push the changes to GitHub, it's also going to automatically rebuild the website for you. So you don't actually you don't have to
Oh.
touch the website manually. And if you go to, for example, GitHub Actions, right? So every time if I commit something, it's going to go through all the testing. So it can help you test the package like on multiple platforms, for example, Linux or Windows or Mac, right? Everything is being built here, and also the documentation. And if you release a new version of your package, you can also have an automatic workflow. The PyPI is going to automatically release this one to PyPI or other channels. So you don't actually have to manually upload the package to PyPI. Everything is automatic. So if you set up that correctly, there are a lot of things can do that to make your life much easier. So everything is within the GitHub, and then workflows. You can set up a lot of things in here. So the critical one here is to build, make sure your package can build correctly, people can install. The documentation is basically update the website automatically. So if you need to update anything, I don't have to deal with HTML. Everything basically is just a markdown. So you can go to the after you clone the GitHub repository, right? So if you need to update anything, for example, on the homepage, I can just go here, just write text. So the website is built using Markdown, so it has nothing to do with HTML. But when you push the website to GitHub, it's going to build that as a static website as HTML, so people can just go online and then do that. So I couldn't get used to HTML, and then this is a fantastic way that you can do that, and it's actually very simple and easy to use. You can have kind of the general structure here within the mkdocs, right?
Mhm.
And then after you set up things correctly, then you just need to edit the markdown. You can edit using editor, or you can directly edit directly. For example, if I need to edit this page, you can just click, and you can also do that directly here within GitHub. You make changes, and then
Oh.
after you save the changes, it's going to reflect it onto website in pretty much instantly. So yeah, certainly very useful. So it's something that I started using about a year ago, and it makes life much easier.
This is super productive workflow. I really liked it. And
Mhm.
I got like, so if I have used GitHub page for hosting, but it comes with also a domain name at the end. So did you remap it from gmap.org to the GitHub
Yes. So
domain?
from
Okay,
here,
okay.
so within your GitHub page, you can, if you have a domain, whatever domain that you have, you just need to go to your your URL, and then set up the domain to point to the website, and then after that you can go to your GitHub repository. But you will need to have GitHub GH pages branch, and then after that you should be able to, where it is, GitHub. Oh, because probably I haven't, yeah, I log in, but what? Let me see here. I need to refresh. So there's a setting here on the page that you can change the URL somewhere here. Okay, settings has been checking here now. Okay, they just make changes. So now looks like they have a new location. So all I need to do, okay, so on the left side here, click the pages. And then from here, because the website is hosted on this branch, and you select this one, and then you just put in the name of your repository and your domain name. And then when people go to this one, it will be direct to this one. So very simple. For example, I also have the other one. This is the other one, the Leafmap that I developed. So we click this one, and it's very similar. So if you have the domain, then you can go to the settings, and then pages, right? So you just need to type in this one, okay? But you need to make sure that you have the GitHub pages, that the website is hosted HTML. So if you go to, for example, the package website, and the default branch is just showing the source code, but there's another GitHub pages branch hosting all the HTML files for your website.
So like the main branch had all the code files, but then you had to create another branch called GH page.
You don't need to click. When you set up, you can just select from the drop down list, but you don't have to deal with anything, because this one is automatic using the GitHub actions. So now if you see this one, right, this one is different. This one right now is deployed automatically when they will push to GitHub. So you don't make changes to this one. And if you see any, you can, for example, this is all HTML. So you will be, so this is created automatically using the GitHub actions. But when you set up your domain, trying to direct to the new domain, then you need to select this one, because this is the website. Otherwise, people won't be able to actually see the website.
Oh, I see. I was doing the other way around, where I had created a separate report for the website and create.
No, you can have everything on the same repository. Yeah, integrated.
Using GitHub Actions. I see.
Yes.
Okay.
So if you use mkdocs, and then, for example, this is the one. So you need to install some of the packages. Everything is built using the mkdocs. So if you go to, maybe, let me click this one here. And I'm not sure if this down there or not. So if you click here at the bottom, right, the footnotes. And this is basically an open source package that you can use, and you can use to build any websites. Very easy to use. You can see here how to get started, right? So it's very similar, right? You can see the structure, and there are a lot of things you can activate to make changes, and then very easy to do. A lot of things you can customize. Yeah, very popular, and it's more like modern. In the past, I use read the docs IO, and it's not as intuitive as this one. Let me see here, Geemap read the docs IO. It might still works. I'm not quite sure. Yeah, it still works. So this is the previous one. It was quite popular in the past, but it is more like in the 1990s. It's like a website, but it's not as nice. It certainly has a functionality, but I think the new one is more modern. So you can still have this. Look at it, for example, all the source code is still built automatically using the GitHub pages, but I like the mkdocs much better compared to this one.
Yeah, and I want to clarify one thing. So these pages are static. So if I write a function like JavaScript based function or something, I can't do computation on that website. It's right.
Yeah, so if you want a function, if you have the Docstring, it's going to extract automatically. So, and then you will build automatically, because the mkdocs will extract the documentation from your function and then put it on the website. So some of the things you need to basically do that manually, but for this one, API documentation, these are all built automatically. So if you go to, for example, if you go to the GitHub repository, and if it's under the docs documentation, right? For example, for the comment, you don't really see anything. You don't need to manually do that. You just need to have the name, what you want to solve on the web page, and then just div map, for example, the module name, and then this is going to automatically extract all the functions within that module. For example, if I go to the comments, right, I have 100 functions within here. There's no way I'm going to build the website manually, and mkdocs, the package, will automatically extract all the information basically from here. And it's also very easy. If you, for example, if you write a new function, you can easily use some tools to, let me show you here. All right, so after you write a function, if you need to write upload documentation, you can use a extension called Docstring. Somewhere you can install here. For example, this one here. No question exactly which one. Okay, Python Docstring generator. So this is a very useful one. If you're trying to develop some functions, this is going to make your life much easier. So you can automatically generate basically the template, and then you can use the template to generate. So I can show you here in action. All right. So right click. Maybe this is just one parameter. So I maybe try something like more complicated. Yeah. Okay, maybe this one. And then just right click, generate doc strings, right? And then you have this template. Then you just fill in the template. So it's much easier.
Oh, I see.
You can have all the arguments, right? So if you have some, like, you can get quite complicated. Some function, if you have a lot of parameters, for example, for this one, I can right click and then generate doc strings. Yeah, it looks like it doesn't generate the arguments. It's weird, but so this is how you can to streamline things, make it much faster to write function and then build up the documentation.
Got it. Yeah, actually, like I was wondering, like the website displays the function, but is there any way I can test a function on GitHub page? Because if it's static, it can't do computation in backend, right?
Yeah, it's just a function. So if you want to develop things, you can basically you can develop notebook. You can also have testing on your website. So you can ask GitHub Actions to test all the functions. So you need to write things within your the test folder here. You can test the functions. But for me, I actually use let me see here. When you develop function, you can also develop notebooks to actually go with the function. So if you, for example, if you click here, you should be able to see when the build website is built, it can also execute all the notebooks. So you know exactly whether they're working properly or not. So for example, for this function, right, they're all being executed. So right, the map is all still all interactive. So if you can see from here, right, you can zoom in and zoom out. That means if something goes wrong, the notebook will fail. And this is how you set up here within your the notebook, the mkdocs. You can have a documentation that allow, okay, execute. If you set equal to true, that means it's going to execute the notebook when the website is being built, right? So, and the notebook basically static, but after you build the website, it become dynamic. So you can still, for example, add legend, right? And you can see this. You can see the map. Right? Move things around. You can turn the layer on and off, right? You can zoom in, you can zoom out. So things still very here interactive, and you can also have some animation. For some of the things that doesn't work, then you can try to sync up other ways to test the function. So a couple of ways you can do that. And for example, you can have some animation to show you what kind of things that you are expecting, for example, right?
So it does all the computation when the page is loaded. And let's say if I draw a rectangle and I want to extract the area of the rectangle after the page is loaded, does the
No, that
static
one is
website?
not right now, not possible because it's already static.
I
So
see.
anything that don't involve like really user interaction, you can preview some of those. And once it's done, you cannot. But a user can always go to the, for example, if I see here, they can just click the button and then open in Google Colab, and then they can basically execute the source code from there because the website is just static. It's not really interactive. If you want to do the coding interactively, then people can just come here, then they can install the package, then they can, for example, I can just add a new code cell, and I can move this one up a little bit, and then you just pip install Leafmap, right? and then you just hit run time, run all, run anyway. It's going to install the package and then goes through the source code line by line to, and you're going to basically get the same result as you see from the website. This is the final output, but this is like very low barrier. Anyone with the internet access, they should be able to create a map interactively without. You don't really need to write any line of code. Right? As long as you can understand, you can see the map, right? Very nice. You can see the map interactively, and then you can draw a rectangle or drop a point or something like that. You can also make that. You can edit, right? You can make changes. You can edit map, right? And you can see this, right? You can have different base maps. Right, so you can zoom in, you can zoom out. Think about this. If you need to download the data, this is 1 meter for the US. It's thousands of terabytes. There's no way you can do that on your computer. Right? And you can also move things around.
So, like, I'm a bit confused because like Colab uses a virtual machine, which is like either GPU or TPU,
Mm.
but even like that has some limitation on competition. So it's not cloud compute like directly because it's a another virtual machine. Like, is it when you say terabytes of data compute? Is it
Oh,
using
this
Google
one is
Earth
not,
Engine?
but because keep in mind, if you use Google's engine, it's cloud computing. So the computation is in the Google Earth backend. The Google
Ah,
Colab is basically just doing the visualization. The computation part is not done on here yet. It's something remotely. So it's Google Colab is just an environment for you to do coding. You can certainly do some analysis, but you won't be able to because the memory is only like maybe 16 gigabyte or something. It's not much, so you won't be able to do a lot of complicated stuff. And the leaf net, this leaf map is just doing some mapping. It's not really much computation here. But if you use Gmap, then you can do that. You can use that to do computation to access terabyte data. And so the reason for this one is that, for example, if I trying to extract some information, I can draw a rectangle, and then you can use the app to actually do the computation to quickly and then return the results. So the computation is done on the Google's engine side. If you want, I can maybe let me see if I have any example here. So if you go to my tutorials, right? So if you go to, I'm not sure, probably somewhere 39, for example, create lane set timelapse animation without coding. So you can look at the imagery if you want, but I can quickly open this one just to show you, for example, create something like this. You're going to go through tons of satellite images, 30, 40 years, and do some mosaic, do some analysis, and then add some animations to this. So if you go to 39, not the video, me the notebook. Right, so you can click notebook, and this is basically the source code behind the scene. This is using computation using Google's engine, so I can show you. Let me see if it still works. Right, this one is hosted on Heroku, so it's kind of a web
ah.
app, and you can do that for doing all kind of analysis using Google's engine. So the computation is not done on Heroku, right? It's similar to just a Google Colab, but user will be able to, for example, I can go to anywhere, I can select a certain location, and then I can also, I'm not sure, you can source, for example, source, for example, ROC, and then, oh, I can zoom in a little bit, right? And then I can, maybe this one I don't need, I can clear all, and then I simply draw a rectangle somewhere. And then you should be able to customize, for example, all these parameters like you like. And I can just use the default, and then you just click create time lapse. So this might take 20, 30 seconds, and then eventually you're going to be able to have the animation. As you can see, this one is going to got all the satellite imagery and then mosaic them together. It's going to take a while if you do it on your personal computer. but essentially the app is getting the coordinates and then send uh, execute the function, and behind the scene is using a Google Engine computing power to do the processing, and then after that return the results and then display that on the map.
I see. So like, so when one is drawing rectangle, it's extracting. It's like minimal compute is done on the personal computer or virtual computer
It's
in
actually no
Colab.
really, there's no compute. It's just draw a rectangle, get the coordinates, get a bounding box, and then pass into the function. Behind the function is that function is requesting computing resources on the Google's engine and then get the results. So here it's basically just sending the request, basically.
So it's calling API of Google Earth
Yes,
Engine.
yes, right. So
Oh,
now
I
we have
see.
this,
Okay, 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 okay.
right? But
Mm-hmm.
if you personally, if you are trying to create animation like this, you need to go online, you need to go the imagery, you need to filter the cloud. And this one is basically like there are tons of imagery being used just to generate this animation. It's not like every year, because every year you have maybe 30, 40 images. You need to combine it all together to get the best pixel for that year and then mosaic them together. Sometimes you might cover multiple image scenes, and it takes a while, but this is can basically automate the scenes, and this is a graphical user interface. And you can certainly also download this one to a computer, right? So you can download this one, click the URL, and then you can use that on your website or others. So this is basically the visualization and the computation is separate. So computation is done on Google's engine, and the visualization is done here locally after the result are being retrieved to your app.
Yeah. So it's one is drawing rectangle, sending a request to Google Earth Engine API, then
Mhm,
it's computing the animation, then and then it's reading back on
mhm,
the interface, and we are
mhm.
just it's yeah.
Yeah, so basically just like you have someone that basically, okay, okay, I want to get this one done. So please do it for me. And then Google say, okay, I'll do it for you. And then here's the result. And then you get that you put it on your computer. That's it.
Yeah. And is the animation stored like after the animation request is done on Google Earth? Is it stored in the memory locally? Like all.
Basically everything is like temporary. They might store for like very short period of time, but things get clear after all. So otherwise there are
Uh,
tons of data they store because people are doing a lot of computation and they are not say storing all the results. And all the computation is done in real time. So right now, if I zoom to another location, and then I can simply make another request for example, let me show here maybe one great example here is pool. So for example, I can do it in here. I can draw another rectangle. You can not only request the image, you can also change all kind of settings. For example, different band combination, how you want that to look. You can also extract water. For example, I want to extract water from this one, and then you can maybe set a threshold or something, maybe slightly larger, and just create, right? So it's going to, again, it's going to send the request to Google's engine, and Google's engine work on that, and then after that, it's going to send you the results back. So and in that way, you don't need to do. You can do this one, or even on your iPad or your cell phone. If you can make it to draw a rectangle, and then you can display the result interactively without having to really rely on anything on your the computing resources on your computer.
that's very interesting. Like if one can do it in iPad, I thought the animation file would be heavy, even if it's like local temporary. But
Mhm.
oh,
Yeah, so it can be anywhere. So this is like global scale. It doesn't matter where you're located. You can simply draw a rectangle and then just adjust the parameter. For example, what's time span you want to use, and then you can create this as something easily without having to have any GS skills, right? Anyone can draw a rectangle on the map and then click the button. That's it. So my goal is to make it easier for people to utilize this kind of a computing, and it's free, right? So now you see this one, right? You can extract the water. You can see this kind of animation. You can have add labels. You can add things to that. And so let me see here. Uh, the internet might be a bit slow because I'm kind of video, but you can see, for example, also upper right corner, right? You can see the
yeah.
changes, and you can also you can turn the layer off if you want. Uh, here my internet is a bit slow, but you can explore the app and then trying to see the changes. There are a lot of people on the internet that use this one to do all kind of interesting applications.
Mhm.
You can do that for large scales, right? So it depends on the location you are interested in.
This is super insightful. And like I'm thinking like, for example, once I get this animation, uh, I want to extract the data out of it. Like, can I make like extract the amount of water from this raster images like in the whole sequence, or do I need to do frame by frame?
No, you can do that. Like I also have some other apps that you can do that automatically. So let me see here. I might have the other one. I think I have another. It's a bit slow here. There's another update. For example, you can do that for water. You can do that for any other application. I think it's maybe number 40 or something. Water app, for example. Right. And similarly, I have some links in here. You can click the link. You should be able to open that one. Ooh. Not this one. Still. Right. So this is another one to map the water. Like what you're saying, if you're trying to extract, for example, the temporal dynamics of the water, then you can use this app. You can click your button. Uh, for example, you can draw a rectangle anywhere or polygon, or you can similarly also, for example, I can zoom into any location, and then you can click on your mouse. You'll be able to actually extract the water. So I can see, let's see, let me try to find one, and you can click your mouse on the map. It's going to select the county, and then you can just simply you can adjust the parameter if you like. If you want to draw a rectangle, you check the list box, and then you just hit submit. It's going to do all the computation and then extract the water for the specific area, and then show you the graph, the temporal chain for that graph. Right? You will see the imagery. It's doing the computation, and right now it's doing computing. And so after a couple of seconds, it might show you the graph to see the changes from the 1980s. It automatically extract the water, and then going through all the years. Every year you're going to get one value, and then you will see the trend. So this is basically everything done in real time. It doesn't store any results on your computer or on Google's engine. So it only compute when you request.
I
This
see.
one is more computation intensive. So right, you see the changes. Now you see the graph, and then you can zoom in, you can zoom out, you can see the changes. You can also download this one if you want. You can download the changes. So this makes it much easier. You can see the area, you can see the pixel. So you have an idea like is the water increasing, is the water decreasing, something like that.
I see. And is it like can I customize the footprint, or is it I need to select county wise?
No, you can do that anywhere. Like I said, if this is for the US, but if you're interested in other location, you just zoom into whatever location you're interested
And draw a rectangle. I see.
in, and then you can just simply draw a rectangle. But you need to check this one here, user zone RI, and then you just submit. That's it. So it's also no user RI is found. It might take some. Yeah, it should be able to do that. So just maybe the computer is like, so
Yeah,
sometimes it takes a while to actually
I got.
pass the RI to
And
user internet.
so for example, I'm just curious how you develop that function. So from Google Earth Engine, you got like the water footprint, and based on the raster value, did you extract like what's the area of that
Yes,
below
so that's
pixel?
basically things based depends on Google's engine. So it is you need to know Google's engine in order to be able to do that. So all the computation is done using the Google's engine API. You can go to the Google's engine webpage to learn more about it. I also have a YouTube, a lot of a YouTube video that show how to use Google's engine. So that one is a total different. Like it takes time to explain all the technical detail, but Google's engine has the API to do the classification, to extract the imagery, and then do the computation, calculate the area, and then get the time series, and then how to do the looping for all the images. So it gets quite complicated. If you go to the, you can certainly look at the source code, but it's a lot of lines of source code if you want to do that. So that one is
And
certainly not like you can do that within like couple seconds or minutes. It takes many hours and days actually to simplify the things so the user don't have to task the coding, but they will be able to still get the results just using some click your mouse.
I see. So like it's really important to like review the documentation of both Google Earth Engine and Gmap.
Mhm.
Yeah,
Yes, so you can look at all the functions. I think it might be somewhere comments, comment.py, and it might be, I think it's called add. Let's say add, maybe lane set time lapse or something like that. Mhm. For example, it's trying to create the lane set time lapse animation, right? So these are the functions behind the scene. Uh, all the parameters that use it can either specify. And if you scroll down here, uh, I'm not sure how many lines of code, but it's actually quite complicated because this is one line. But if you go to another function, for example, here you can. So all the functions might call other functions, so it sometimes get quite complicated. And you can go to the next one here. Like all the functions, some are like quite long. Some laws might be more than 1,000 lines of code. If you want to do that.
I see.
Mhm.
It is quite like I really like how you also went a step ahead and extracted the values to make it more
Mhm.
useful for the end users. So
Mhm.
yeah. Is there anything else like since we you're sharing the screen, one should be aware of in the documentation or the functionality aspect?
Uh, there are a lot of information just on the webpage, so I highly recommend that you are interested in, you can learn more about it. And you can, if you're interested in, if you don't have a Google's engine account, you can maybe try out the Leaflab. So go through the documentation, and then for the notebooks, you can just directly see the result. But keep in mind, these are not all the functionality because it's using the volume. Volume is basically after map is created, you can only zoom in and zoom out. You cannot really remove a layer. You click the mouse, it cannot give your coordinates. So if you want to try it out, it's better to use Jupyter Notebook. So you install the package on your computer, then you can try it out to have more interactive functionality. So you can see all the notebook. I also try to make some animation so people can just, for example, these are the buttons. These are not available here on the website. But if you install on your computer, you can load the data on your computer. You can add some, for example, some data, and you can see all the attributes. You can also, there are a lot more things you can do using the graphical user interface. It will be a lot more useful if you're trying to use this package. So use Jupyter instead rather than Google Colab.
Yeah, like one thing when I was getting started with this package is like I went through the notebooks, Colab notebook first, tested few functions, and then if I wanted to know more about the functions, I went to the documentation that what are the functions I could call, and then started adding
Mhm.
more functions in the Colab script, and also like YouTube tutorials help. So I think it's a pretty good workflow if one is getting started to use this package.
Yeah, you can some of the functions, most of those are basically shared between Gmap and Leaflab. So a Leafmap, so you can check those functions, see anything useful. You can do a lot of basically conversion between different data format. You can also retrieve, for example, OpenStreetMap data and then convert it to something that can be, you can display this directly on the map. So anything you're interested in, look at that and then just click the function, and then you'll be able to see all the source code behind.
Got it. Thanks a lot for sharing all the insights and the backend process. It was super helpful to me personally, at least. Like, cool. So I have like few questions which I'd like to uh, ask, and like I know it's already like above 1 hour mark, so I want to be conscious of your time. So
Mhm.
um, the next question I have is like, can you share some examples of real life applications people have developed using Gmap, and like either on like uh, analysis or visualization side, and also like on data science or machine learning aspect?
So if you're interested in machine learning, you can. I also have the website have some examples, so you can study. If you go to GMAP tutorials, and somewhere there, I think it's 30, 34 or something. Like machine learning using unsupervised classification, supervised, and also accuracy assessment. So you can certainly look at some of those examples and see what's available. What kind of things you can do with Google's engine. So let me see here. You can also see what kind of algorithm available within the Google's engine API, right? So unsupervised, you can also do supervised classification and some of the algorithm, but they're still developing. There are a lot more things you can do. So these are things that apply on Saturday. They are not on computer science like JPEG and photos or something like that. It's totally different. So and they're locked. So Google Gmap is just a tool. There are a lot of things you can build up to do on the application. So for example, some of the real world application, the tool that I showed you earlier, how to extract the water, how to calculate the area, and how to create a lot of animation. So those are some simple application, but it based on your imagination. If you have something that you want to do, and most likely you'll be able to find something that you can build up using Google's Engine API to do a lot of computation. And the other thing is to, if you want, you can look at the web page, see what other people are using the package for. So if you go to the page and then, for example, used by 122, you can click and see what other people are using the package to do what, right? So for example, resource project, and then some, for example, detection, whatever. Try to see, have an idea. For example, machine learning for flooding, right? And some of those actually quite popular. So you can take a look at what are they using that, and it might be useful to get some idea, right? How they're useful to build up some application, for example, to take a look at this. Quite interesting. So even personally for myself, I don't have time to go so often, but there are certainly a lot of things that you can do with Google's engine and Gmap. Uh, it's free, so you can, if you have time, just try it out, and hopefully you can come up, for example, lane use, lane cover, all kind of stuff available.
God, yeah, there are a lot of possibilities with it. And according to you, like what kind of tools or technologies in GIS or geospatial data science would be common like 5 years from now, but like not widely used today?
For now, I think the cloud computing is like something like Google saying is still is quite popular right now, but still it has a lot of room for improvement. And so in moving into the future, I think it's things are moving to the cloud. So eventually, people just need a browser. You don't need to have a fancy computer, but you can do a lot of cool stuff using the cloud computing resources. For example, Microsoft just released another one, kind of a competitor to Google's engine. Is called planetary computer. So that one is still right now in private review, but uh, plan computer Microsoft. So you can take a look at that one. For example, right. So these are things that right now is still in development. You can take a look here. You can request access if you want. And there's another one called, for example, linkcover.io. This one is hmm, development C. I think okay, link cover. Yeah, my internet a bit slow, but there are lots of cloud computing stuff and also deep learning stuff happening in the geospatial community, and a lot of people are using it to do a lot of very useful application. You can take a look at some of those links, like people how can use to do it similarly, just draw a rectangle and then you can do all kind of classification on the map, and then you can go get all the statistics. So it's quite useful. So you can also draw, for example, training data set directly on the map, and then to classify those imagery on the fly, to fine tune the model and then get better results. So these are things that certainly I think is moving very quickly, and you'll be useful for a lot of applications, and also lower the barrier. So anyone with an internet access, they can try out these kind of applications, and then to also download the results, and then to do some things they want to do using this kind of satellite data.
I see. Like
Mhm.
it's cloud compute, easy to use,
Mhm.
machine learning interface and code, like data visualization and uh, things. Yeah, I see.
Yes. Mhm.
And now I'll move to the final section about advice to students and professionals. Uh, what will be your advice to people who wish to do similar work?
Yeah, certainly it depends on your goal. So if you want to get into the coding, probably need to learn how to use Gig, how to use GitHub, and learn one programming language very well. So Python is something that you can easily get started, and you just need to spend some time to get used to GitHub, and then read through some of the most important open source packages or repository available there, and look at the source code, look at the novel example, learn how other people are doing that. Eventually, you can build something on top of others, so that just to make life easier for yourself and also make use life easier for other people. Eventually, you can become also a contributor to the open source community, and establish yourself, so people know when people trying to look for something, when they put something um, search something on Google, you want something to come out. You want your stuff to come out on the first page, and you can make it happen. Then that means right now you are making an impact, right? So otherwise, if you people search your name or search your package or something related, if it doesn't come up in the first page or two, that means people won't reach you. So there's something you want to keep in mind if you want to really making an impact on the community.
Yeah, that's a great piece of advice. What are some books, conferences, or courses you would recommend to people who want to develop expertise in this area?
There the other one you might check Medium, right? So it's like another blog, Twitter, but longer one. So Medium, there are a lot of very interesting stuff. If you want to do some technical stuff, this is definitely a website that you need to also look into. And I used to read a lot of things from here every day, and especially in the computer science or deep learning or machine learning, there are a lot of things happening in here. And also check out some of the Google. There are tons of tutorials. So nowadays, if I want to learn something, I just type into YouTube and then try to find something, and then from there you can find out more resources. There are a lot of free courses online, so you don't really need to really to purchase any video or courses from the internet. And the other thing is use GitHub. So if you know how to do the coding, once you know the basic, you can read some books. There's just too much. So right now, I don't really read a book from the beginning to the end. I'm more like problem oriented. So if I'm doing something, I don't know how to do it, I just Google and then just read the documentation, and then you be able to implement. But if you want to have some systematic learning, then you can find some books on the, GitHub, or there are right now a lot of open source books. So you can read from the beginning to the end. But my recommendation would be to have something more practical project they can work on, because if you're reading a book, sometimes you just practice, you don't really get things into your mind, because once you execute a software, you forget. But if you have to have a project, you need to come up with an idea and then design the project and then how to implement. You have more practice and then more hands-on. Eventually, you really learn the stuff. So you need to have a project, an idea. For example, if you want to build onto a package, okay, think about what functionality you want to provide. How do I define the function? How do I write the documentation? How do I publish that one? So um, there are lots of things you can do if you want to really get into the coding environment. But it, basically it's just Google. That's it. Google is the best friend. So if you need to learn something, you need to find anything, Google it, and then try to identify the best resource, and then go from there. Once you get into one component, there might be a lot of other components in between, and then you can continue to learn more. So once you become comfortable, then it's better to be more oriented. So you're focused on specific target or project, and then you just use that. If you have any issues, go to a GitHub repository. If you're using any package, just report on the GitHub issues, and then those developer or the maintainers, they might give it to you. So get things fixed pretty quickly.
I see.
Mhm.
And is there any topic or area we didn't cover in this live stream and you want to share some thoughts?
I think we've talked about most of those. Not sure what to other topics, but certainly, I mean, deep learning and machine learning is we stay for many years. So if you in the if you want to get into programming, certainly you need to have some skills in this. For example, some of the common deep learning libraries, TensorFlow, PyTorch, or others, and how to try to follow some of the latest development in this area would be certainly very useful, and how to especially, for example, data science, data analytics. So those are things that will be here for many years to come. So if you want to get a job in that area, you probably need to learn some of those skills, how to use GitHub, how to do coding, and but this is not everything. There are a lot more things in life that you can learn, but the more important thing is to have the capability. So if you know how to learn one language, you can certainly learn many other languages. So and utilize the resources, utilize the internet to learn by yourself, and then teach yourself something new every day, and then eventually contribute back to the community.
I see. And like most of the machine learning applications I've seen in this domain is like more kind of on computer vision side for like image segmentation, object detection, like
Mhm.
more on like raster images. Is there like any geospatial based like, uh I don't know, like data, like correlational data or feature engineering based deep learning model?
Yeah, yes. So anything right now developing the computer science deep learning, somehow people can adapt and then use in remote sensing, because we are dealing with location data. So think about any raster imagery or vector data. It's all location related. So you have coordinates, you have pixel, you have other values. So it's a little bit more complicated than the traditional just using JPEG or other PNG images. So you can certainly, usually it's more computationally intensive compared to just simply photos and pictures. But there are a lot of things that we utilize from the computer science development.
Got it. Yeah, like when we were discussing initially about like different data values associated with, let's say, land features, like one straightforward like application I that came to my mind is regression algorithm to predict things in future. So
Yeah, that's a very common one in remote
yeah,
sensing. You can do regression, you can do classification. Most of the common remote machine learning algorithms can be used in remote sensing data.
got it.
Mhm.
Yeah, and how can our listeners, if they are interested in contributing to
Mhm.
open source in Gmap or Leafmap, reach
Mhm.
out to you, or if they want to know more about you and your work?
Yeah, so the best way is just to go to the webpage, for example, Gmap, and then you can reach good documentation. If you have any question, you can go to the GitHub page, and so you can report bugs, for example, the issues, and you can open an issue here, or you can go to the discussion page. So here, people ask tons of questions. So you can go through what kind of question the people are asking, and usually gets answered pretty quickly. So you can look at those answers, right? And hundreds of questions have been asked and answered. So something related to the Geemap and Leafmap, you can just use GitHub. But if you have other questions that are not related to GitHub, then you can send me an email. You can go to my website to look for my email and other ways that you can contact me, or you can follow me on Twitter or LinkedIn. You can also text me from there.
Yeah. All right. I think that's it I have from my side. And I really want to appreciate Professor Wu for your time. Throughout the session, I could literally feel the passion you have for this topic, and you went quite deep into various aspects about your work, which I really like. And even like when I reached out to you on LinkedIn, you were quite approachable and humble. So I really appreciate that.
Mhm. Yeah, thank you very much for having me. I enjoyed the conversation. So hopefully it'll be useful for people out there that are interested in data science or machine learning and deep learning. Although we don't really cover a lot about the topic, but there are a lot of things online you can find and to learn more about this topic.
Okay. Thank you. Have a nice rest of your day.
You too. Thank you. Take care.
Yeah. Bye
Bye
bye.
bye.